The storm desk. Read the storm, book the roofs. A representative walks in, waving a hail map, a fat-colored polygon over your whole market, and he wants to bank the storm and tell homeowners their roofs are already gone. Stop. By the end, you'll know what a hail map can prove, what it can't, and the one sentence that keeps every estimate honest. Radar justifies the inspection. The inspection justifies the scope. I've watched a clean map get a file denied because someone asked a polygon to prove a thing only a roof can prove. Start with what radar actually does. It sends a pulse and listens for what bounces back. Hail throws a strong return, but so does heavy rain, so older radar confuses the two. Modern U.S. radar is dual polarization. It pulses both ways and reads the shape of what it hits. The National Severe Storms Laboratory says it can help tell hail, ice pellets, and rain apart and rough out hail size. But it's reading objects thousands of feet up in the storm, not a stone on your customer's driveway. Now meet the product on most hail maps. Mesh, the maximum estimated size of hail, a post-storm guess at the biggest stone a storm probably held, smeared across a grid. Two facts belong in every estimator's head. First, the grid is coarse. One cell covers roughly a square kilometer. 1 pixel can swallow a whole subdivision. Second, mesh estimates the maximum, not what fell on a given roof. A map colored for 2-inch hail over a neighborhood doesn't mean 2-inch hail hit that house. It means a storm could make 2-inch hail somewhere in there. Here's the scale problem in one picture. A radar cell is measured in square kilometers. A roof plane is measured in square feet. Even a perfect cell value averages a space thousands of times bigger than the roof you estimate. Then add how hail falls. It doesn't coat a street like snow. It falls in swaths and streaks, sometimes a few hundred yards wide, steered by the storm winds. One side of a street gets hammered, the other barely touched, and on one house, the storm-facing slope and the sheltered slope tell different stories. Radar reads the air and estimates downward. So what is the size estimate good for? A sanity check before you ever climb. Inspection guidance treats hail around 1 inch, about a quarter, as the informal line for functional damage on standard asphalt shingles. Smaller stones mostly hurt older, worn roofs. So if the best estimate is half-inch hail and the roof is new, the physics argue against damage, and you can say so plainly. 1.5 inches on a 15-year-old roof says look closely. The estimate sizes the odds. It does not write the scope. Now the trap that sinks files. Granule loss, the most overread sign in estimating. Asphalt shingles shed granules from day one. Manufacturing, sun, foot traffic, plain water flow into the gutter. A handful in a downspout proves the roof is asphalt and old. It does not prove hail. Hail loss has a signature. Discrete impact points, often with a bruise, a soft fractured spot under the granules, randomly placed and directional. The bruise is the tell, not the bare spot. Document baseline wear as its own line, and the findings read careful, not convenient. Here's the move that turns a polygon into a file that holds. Build the estimate in layers, weakest on bottom, strongest on top. Layer 1 is climate context, why the area is hail-prone. For planning, Layer 2 is the weather event, radar, mesh, storm reports, proving a storm of a given strength passed near and when. Layer 3 is the customer timeline, the date they remember hail on the windows. Layer 4 is the inspection. Never let a lower layer do an upper layer's job. Quote a hail map like an inspection, and you've built the file a desk adjuster denies first. Date the event precisely, because that's the one thing radar does genuinely well, and it anchors the file. A vague "sometime this spring" invites the pre-existing where argument. A specific date and time closes that door. Pull the Storm Prediction Center report archive for the area and time frame, and match it to what the customer remembers. When the record and their memory agree, you have a defensible event date. When they disagree, note both, because it might be 2 storms, and the roof sorts out which one fits. A screenshot with no date is decoration, not evidence. Roof age is half the analysis, not a footnote. A 3/4-inch stone bounces off a 5-year-old architectural shingle and bruises a 15-year-old 3-tab already worn by sun. Same storm, same street, opposite outcomes. So treat roof age as a band, not an exact year. Asphalt shingles broadly run 15 to 30 years depending on type and install. A scope that assumes storm damage on a roof of unknown age is the easiest denial a desk adjuster writes. The map size the storm. The age tells you which roofs that storm could plausibly have tipped over the edge. Make the proof on the roof, not the map. Inspectors look for functional damage, impacts that compromise how the roof sheds water, not every cosmetic ding. The chalk circle test square is the standard. Mark a 10 by 10 foot square on a slope, circle each impact, photograph it with the slope, address, and date. Repeat on each slope so the directional pattern shows. Then read the soft metal. Gutters, vents, downspouts, flashing, AC fins dent at known energies and don't lie about direction. A vent dented on its north face and clean on its south is a record the air can't fake. Here's the line, and it is not subtle. Your job is to document what you see and write a clear estimate. Running the claim is not yours. The insurer decides coverage under the policy. The homeowner owns the claim, and the deductible is theirs to pay. So separate functional damage, generally covered, from cosmetic, generally not, by area with reasoning. Never write insurance will cover this on an estimate, because that promise steps you out of the contractor's lane and into the carrier's. Document. Don't diagnose the claim. State what the roof shows. Let the policy decide. Keep the homeowner off the roof. Falls from roofs and ladders are a leading cause of construction deaths, and a customer has no gear. Never tell a homeowner, climb up and send me photos. It's a liability you don't want, from the ground and inside only. Have them photograph what's safe. Dented gutters, downspouts, window screens, spatter on a fence. That collateral is strong evidence. Then a trained, insured pro climbs. Put one line on the leave behind. A hail map does not, by itself, prove a roof is damaged. An on-roof inspection does. Your cheapest roofs in this storm aren't out on a cold street. They're already in your records. Every declined estimate, every "call me next year," every roof you installed a dozen seasons back is an aging surface. A marginal storm can push past the line. Same physics as the whole topic. A small storm does little to new roofs and a lot to old ones. Your old book already knows which contacts have old roofs because you quoted them. Cross that against where the storm tracked, before you've built a root, and a cold canvas turns warm. Here's where RoofPredict fits and where it doesn't. It pairs an estimated roof age range with storm physics modeled per home, scoring which roofs a real storm most plausibly wore out, instead of flagging everything the polygon covered. That sharpens the outbound and skips brand new roofs that waste a crew's day. It does not climb the roof, see granule loss, diagnose a bruise, certify life, or decide a claim. Roof age is a planning range, not an exact date. The storm score is a likelihood, not a finding. Software narrows the list. A person inspects the roof. The inspection writes the scope. Close the loop. Radar can prove a hail-bearing storm passed near, and when, and roughly how big the stones might have been. It cannot prove a shingle was bruised, the roof needs replacement, or a claim should be paid. So radar justifies the inspection justifies the scope, and roof age decides which roofs the storm could plausibly have worn out. Document what you see and write the estimate. The insurer decides coverage. The homeowner owns the claim, the map opens the file, the roof writes the scope. While the chasers knock blind, you bank the roofs that are actually due.